Okay, hello student. Welcome to Darasa Online. My name is Edgar Mshana. I'm teaching advanced mathematics. In this part of presentation, will be the topic of differentiation. And in this topic, we are going to discuss the introduction to partial derivatives, in which we are going to start with first order partial derivatives, followed by second order partial derivatives. Then at the end, we are going to have an assignment. Dear student, join with me until the end of this lesson. Welcome. Now, student, let us start with introduction to partial derivative. As I said earlier, we are going to start with the first order partial derivatives. And here, in partial derivative, we can define partial derivatives as the derivative of a function of two or more variables with respect to one variable while other variables are constant. In this case, we are going to differentiate a given function with respect to one variable while the second variable is constant. And in this part, there are some notations usually in first order partial derivatives. One of them is this one. This means the partial derivative of z with respect to x. In this case, y is constant. When differentiate z with respect to x, y is constant. Then the second one with the partial derivative of z with respect to y. In this case, x is constant. Now, after learning these notations used in first order partial derivatives, now let us have some examples here. We are having 3 examples. Starting with the first example, find the first order partial derivatives of the following. Starting with Roman 1, we have z is equal to x squared plus y squared plus 2xy. We are supposed to find the first order partial derivative of this function. Now our question, that is, we have z is equal to x squared plus y squared plus 2xy. We are supposed to find first order partial derivatives. Now we can start with that is solution. Let us start with partial derivatives of z with respect to x. In this case, y is constant. So here we are going to have, we are starting with x squared. Differentiating x squared, we have 2x plus the next variable is y squared. But in this case, y is constant. So differentiating y squared, we are going to have 0. Then plus, we have 2xy. Remember, we are differentiating with respect to x. So in this case, y is constant. So we are going to have 2y. Now in this case, the partial derivative of z with respect to x will be equals to 2x plus 2y. Now in this case, we say the partial derivative of z with respect to x, this one is equal to 2 bracket of x plus y. Now, dear student, we proceed with another first order partial derivative. Now, in this case, we have the partial derivative of z with respect to y. This time, x is constant. So, in our function, we are starting with x squared. So x squared, that is a constant. So differentiating x squared, we are going to have 0. So in this case, we have 0, then plus the next variable we have y squared. Since we are differentiating with respect to y, differentiating y squared, we have 2y. Then we have 2xy. Remember, x is constant. So differentiating 2xy, we are going to have 2x. Now in this case, this one is equal to 2y plus 2x. Therefore, the partial derivative of z with respect to y, this is equal to 2 bracket of y plus x. That is Roman 1. Let us proceed with the second one. So in this case, we have z is equal to x squared y minus 3y squared minus 4y. So our second question, we have z is equal to x squared y minus 3y squared minus 4y. So in this case, we are looking for the first order partial derivative. So the solution let us start with the partial derivative of z with respect to x. In this case, y is constant. So here we are going to have, we have x squared y, that is 2xy, since y is constant. Then minus, we have 3y squared. Remember, y is constant. So differentiating negative 3y squared, that is equal to 0. So here we have 0. Then minus, we have 4y. Again, remember, y is constant because we are differentiating z with respect to x. So the derivative of 4y, this one is equal to 0. So in this case, we say the partial derivative of z with respect to x, this is equal to 2xy. So dear student, we proceed with the second partial derivative. This time we have the partial derivative of z with respect to y. This implies that x is constant. So we are using the same function. Our starting point is x squared y. So in this case we have x squared. Then we have y squared. So this one is minus 6y. Then minus, we have 4y. So this one will be 4 sec squared 4y. Then the second question is ready. We proceed with the last one. That is z is equal to x squared plus 3xy plus y minus 1. So in this case we have, that is Roman 3, we have z is equal to x squared plus 3xy plus y minus 1. I'm sure you remember the starting point. That is the partial derivative of z with respect to x. I'm sure you remember when you find the partial derivative of z with respect to x, y is constant. So in this case, we have 2x, then plus 3y, then plus 0, minus 0. Because y is constant, differentiating y, we are going to have 0. And again, differentiate negative 1, again we have 0. So here, we say the partial derivative of z with respect to x, this one is equal to 2x plus 3y. So we proceed with the last first order partial derivative. Now this time we have the partial derivative of z with respect to y. Again, you remember, x is constant because we are finding the partial derivative of z with respect to y. So here we are going to have, that is 0, then plus, we have 3xy. In this case, we have 3x. Then plus, differentiating y, that is 1. Then minus 0. Therefore, the partial derivative of z with respect to y, this one is equal to 3x plus 1. So, dear student, let us proceed with the second order partial derivatives. That is second order partial derivatives. And again, here we have a special notation for second order partial derivatives. Now, the first one, that is the second order partial derivative of z with respect to x. And the second one, we have the second order partial derivative of z with respect to y. In the first case, y is constant. But in the second case, x is constant. But again, we have other notations for second order partial derivatives. And the first one, we have second order partial derivative of z with respect to y and x. And the second one, we have second order partial derivative of z with respect to x and y. So these are the notations used in second order partial derivatives. So dear students, again, let us see some examples of finding second order partial derivatives. And in this case, we are supposed to find all the first and second order partial derivatives of, for a, we have z is equal to 4x squared minus 8xy power 4 plus 7y power 5 minus 3. So, students, our question, that is a, we have z is equal to 4x squared minus 8xy power 4 plus 7y power 5 minus 3. We are supposed to find all the first and second order partial derivatives. Now, let us see our starting point. So in this case, we are going to start with the partial derivative of z with respect to x. In this case, y is constant. So here we are going to have 8x, then minus 8y power 4. Now we have 7y power 5, but y is constant. In this case, we have 0, then minus 0. So, partial derivative of z with respect to x, this one is equal to 8x minus 8y power 4. So we can proceed with the second order partial derivative of z with respect to x. So this time we proceed with the second order partial derivative of z with respect to x. So again, y is constant. So in this case, differentiating 8x, we have 8, then minus, we have 8y power 4. Y is constant, so in this case, we have 0. So the second order partial derivative of z with respect to x, this one is equal to 8. So we proceed with another second order partial derivative, as I said earlier. So in this case, we have, that is the second order partial derivative of z with respect to y and x. But this one can be written as, this is equal to partial derivative with respect to y of partial derivative of z with respect to x. But the partial derivative of z with respect to x we have, which is the same as 8x minus 8y power 4. So we have to substitute the value of partial derivative of z with respect to x. So in this case, we have the partial derivative with respect to y of this one, the same as 8x minus 8y power 4. So since we are differentiating with respect to y, x is constant. So here we are going to have 0 minus, that one will be 32y power 3. So in this case, the second order partial derivative of z with respect to y and x is equal to negative 32y power 3. So dear student, we proceed with the first order partial derivative, but this time it will be with respect to y when x is constant. So in this case, we have partial derivative of z with respect to y. That means x is constant. So in this case, we have 4x squared, differentiating 4x squared, that is equal to 0. So here we have 0. Why? Because x is constant. The next we have negative 8x y power 4. So in this case we have minus, that is 32x y power 3. So we proceed with 7y power 5. In this case, we have 35y power 4. Then on differentiating negative 3, we have 0. So in this case, we say the partial derivative of z with respect to y when x is constant, we have negative 32x y power 3 plus 35 y power 4. Now we proceed with the second order partial derivative. That is the second order partial derivative of z with respect to y. This one is equal to, remember, x is constant. Now if x is constant, we are going to have, that is negative 96 xy squared, then plus, we have 35 times 4. This one will be 120. 40y power 3. So another second order partial derivative, that is the second order partial derivative of z with respect to x and y. This one is the second order partial derivative of z with respect to x and y. This one can be written as the partial derivative with respect to x of partial derivative of z with respect to y. But remember, we have the partial derivative of z with respect to y. So in this case, we have the partial derivative with respect to x of, now that one is the same as negative 32 xy power 3 plus 35 y power 4. In this case, we are going to differentiate with respect to x. And if it is with respect to x, y will remain constant. So in this case, we are going to have, we are starting with negative 32 xy power 3. Remember, y is constant. So here we are going to have negative 32 y power 3. Then differentiating 35 y power 4, remember y is constant. So this one will be 0. So in this case, we say the second order partial derivative of z with respect to x and y is equal to negative 32y cubic. So dear student, in your observation, you have seen there is no difference between the answer we obtain when we are finding the second order partial derivative of z with respect to y and x with the second order partial derivative of z with respect to x and y. The answers are the same. Now let us proceed with b. And this time we have this question, that is b. We have z is equal to 2y cubic x squared minus x power 4 y power 5. Let us see how to do this question and see if the answers for second order partial derivative with x and y will be the same. So student, we are starting with first order partial derivative. And of course, you can start with that is the partial derivative of z with respect to x. Remember, y is constant. So here we have, that is 4y cubic x. Then minus, we have x power 4, y power 5. So in this case, we have 4x cubic y power 5. So we can proceed with the second order partial derivative with respect to x. So in this case, we have, that is the second order partial derivative of z with respect to x. This one is equal to, again, y is constant. So here we have 4y cubic, then minus, that will be 12x squared y power 5. So again, we continue with the second order partial derivative of z with respect to y and x. But I'm sure you remember, this one can be written as the partial derivative with respect to y of partial derivative of z with respect to x. And already we have this value of partial derivative of z with respect to x, which is the same as partial derivative of with respect to y of, here we have, that is 4y cubic x minus 4x cubic y power 5. So in this case we have, so we differentiate with respect to y. That means x is constant. So here we have 12y squared x, then minus, this time we have 20x cubic y power 4. So we said the second order partial derivative of z with respect to y and x will be equals to 12y squared x minus 20x cubic y power 4. So dear student, we continue with another first order partial derivative. This time we have partial derivative of z with respect to y. This implies that x is constant. So we have, that is 6y squared x squared, then minus we have 5x power 4 y power 4. For the case of second order partial derivative with respect to y, we have, that is second order partial derivative of z with respect to y. This one is equal to, we have 12y x squared minus, this time we are going to have 20 x power 4 y power 3. And we'll finish up with another second order partial derivative with respect to y and x. So this time we have the second order partial derivative of z with respect to x and y. So remember, as I said earlier, this one can be written as partial derivative with respect to x of partial derivative of z with respect to y. But of course already we have this value of partial derivative of z with respect to y. So in this case we have the partial derivative with respect to x of, now our value is 6y squared x squared minus 5x power 4 y power 4. So on differentiating this with respect to x, y will be constant. So we are going to have 12y squared x minus, here we have 20x power 3 y power 4. So of course this is the same as second order partial derivative of z with respect to x and y. So dear students, now you can compare the answers. The answers are the same. For the case of second order partial derivative of z with respect to y and x, the answer is the same as the second order partial derivative of z with respect to x and y. And the answer is 12y squared x minus 20x cubic y power 4. So in this case, we can make a conclusion as follows. And that is, in this case, we say the second order partial derivative of z with respect to y and x, this one is equal to the second order partial derivative of z with respect to x and y. Okay, dear students, let us proceed with word problems. And that is word problems on application of differentiation and small change. we have the first question, that is, a cylindrical tank is 1 meter high and 0.3 meter radius. If height is increased by 5 centimeter and radius by 1 centimeter, what is the effect on volume? Dear student, here we have our cylinder with height h and the radius r. Our intention is to find the height. Our intention is to find the change in height. So here that is given. We have the height that is equal to 1 meter. But again, we have the radius. So radius is equal to 0.3 meters. And if height is increased by 5 centimeter, here we have dh, which is equal to 5 centimeters. We can convert this into meters. So into meters, this one is equal to 0.05 meters. But again, we have the radius, which is increased by 1 centimeter. So this is dr. So dr is equal to 1 centimeter. So again, 1 centimeter into meters, the same as 0.01 meters. And the student, remember the formula for finding volume of a cylinder. That is, V is given by pi r squared h. Now, let us find dV dh. So in this case, dV dh will be equals to pi r squared. And again, you can find dV dr. Now in this case, dV dr, that is equal to 2 pi rh. That is dV dr. Now for dV, we know that dV is the same as dV dh, then times the dh, this one plus dV dr times dr. So in this case, you have dV is equal to dV dh. We have that is pi r squared, then times dh. Then dV dr, that is dV dr, we have 2 pi rh, then times dr. So in this case, pi, we've given pi is equal to 22/7. So in this case, we have 22/7 times radius squared. So radius squared, we have 0.3 squared, then times dh. So in this case, dh is equal to 0.05. Now this one plus, then we have 2 times pi. Our pi is 22/7 times radius. Now radius is 0.3. We have 0.3. Then it times height. Now the height is 1. So this one is 1. Again times this one times dr. So in this case, dr is equal to 0.01. Now in this case, you can take your calculator and get the final answer. So in this case, the final answer is equal to 0.033 cubic meters. That is dV. So we conclude by saying the effect in measuring volume is, so our answer is equal to 0.033 cubic meters. That is one. So students, let us proceed with the second word problem. This time we have the question that is the angle of elevation of the top of a tower is found to be 30 degrees plus or minus 0.5 degrees from a point 300 plus or minus 0.1 meters from the base. Estimate the tower's height. So of course, dear student, this is our tower with height h, and the distance from the base of the tower is x meters. And here we have the angle of elevation, that is from the top of the tower to the ground. Now our intention is to find the height of this tower, and again the small change of the height. So in this case, that is given, we have angle theta, which is equal to 30 degrees. And of course, d theta, this one is equal to 0.5 degrees. Okay, but again, we have the length, that is xc, is given by 300 meters, and the small change in that length from the base of the tower, that is dxc, which is equal to 0.1 meters. So again, dear student, in our diagram here, we can recall trigonometric ratio, that is tangent of angle theta is the same as opposite, that is h over adjacent, which is x. So in this case, we say that is tan theta, this is equal to opposite side h over adjacent, that is x. Now making h the subject, we have h is equal to x tan theta. Now it is possible to find h because we have x, the value of x, but again the theta, we have it. Therefore, in this case h is equal to x, that is 300 meters times tan theta, we have 30 degrees. In this case, we have 30 degrees. So h will be equals to, that is 173.21 meters. Just use your calculator, take 300 times tangent of 30 degrees. So in this case, we are going to get the same answer, that is 173.21 meters. Now again, that is using, that is h is equal to xc tan theta. It is possible to differentiate h with respect to xc. That is dh dx. This one is equal to, on differentiating dh dx, that is equal to tan theta. And again, let us find dh d theta, that is dh d theta. So in this case, we have xc sec squared theta. So dear student, our interest is to find dh. So in this case, dh is the same as dh dx, then times dx plus, we have dh d theta times d theta. So in this case, we can substitute those values to find the dH. But before doing that, we have to convert d theta into radian. It is given in degrees. We have to convert into radian measure. So in radian measure, this one is equal to, we have 0.00873. This one will be in radian. That is in radian. So in this case, dH will be equals to dH dx. dH dx, we have tan theta, that is tan theta, but this one times dx, plus we have dH d theta. Now dH d theta is x sec squared theta, that is x sec squared theta, then d theta. So this one is equal to, remember theta is equal to 30 degrees. So we have tan of 30 degrees times this one times, now we have dx. In this case, dx is equal to 0.1. So here we have 0.1. Now this one plus, then we have x sec squared theta. Now x, that is 300 times sec squared 30. Now this one times d theta. D theta, that is this time it will be in radian. So that is 0.00. We have 873. That one is in radian. So again, dear student, take your calculator and compute the final answer. So in this case, the final answer will be equals to, that is dH is equal to 3.55 cubic meters. Now our interest is to estimate the tower's height. Therefore, say the tower's height. The tower's height is, now in terms of error, starting with h. Now in this case, h is 173. That is 173.21, then plus or minus. Now in this case, dH is 3.55. That is 3.55. Then this one is in meters. Now you can see how it is so simple to compute the value of h. That is given in terms of errors. Now, dear student, I hope we're together. Now it is time for assignment. Then we have the first question, that is, if f of x comma y is equal to x cubic y plus e power x y squared, then find the partial derivative of f with respect to x, that is when y is constant, and the partial derivative of f with respect to y, that is when x is constant. I'm sure this question is very simple for you. Dear student, let us proceed with the second question. And that is, if z is equal to x squared, tan inverse of y over x, find the second order partial derivative of z with respect to x and y at 1, 1. This implies that after getting this second order partial derivative, you have to substitute value of x and y in your answer, so that to get a number that will be a constant, a number without a variable. So dear student, it is my hope that you enjoyed this lesson of partial derivative, where we discussed the first order partial derivatives followed by the second order partial derivatives. So till next time, Have a good time. Bye.